Hey guys, welcome back to another Leetcode problem solving tutorial, and in this tutorial I'm going to be showing you guys how to solve Leetcode problem 875, Koko eating bananas. Okay, so this question is essentially going to give you an array of piles, which piles of bananas, and it gives you a total time which you're allowed to use. And I want you to output an integer k, which is essentially Koko's eating speed, right? So if k is 4, that means she can eat 4 bananas per hour. And the idea is she can eat, if there's more than 4, like if there's more than 4 bananas in this pile, then she's going to eat 4 and then subtract 4. But if there's less than 4, then she's going to eat all remaining ones, but she's not actually going to move on to the next pile immediately. She has to wait until that entire hour is finished. So let's look at an example of this. Let's just say 3, 6, 7, 11. And we're going to set k as 4 since we know this is the solution. And let's just set, we know h has to be 8. So h is essentially the number of hours that we have available. So first thing that's going to happen is this one's just going to go. So we've used 1 hour of time to eat these 3. Since 3 is less than 4, we can do it all in one go. Then this is going to go, well, this is actually going to take 2 hours, because first it's going to go to 2, and then from 2 it's just going to go to 0. And it's going to take 2 hours to do that in total, 2 hours to do this as well in total, because it's going to take, well, it's going to go to 3 after the first hour, and then it's going to go to 0 after the second hour. And for this one, for 11, it's actually going to take 3, because it's going to take 1 hour to go from 11 to 7, then it's going to take 1 hour to go from 7 to 3, and then another hour to go from 3 to 0. So that's 3 in total. And as you can see, this means the total time is going to be 8, and that fits within our h. So that's good. Obviously, if we can find a k which is less than 4, that's even better. It asks you to find the minimum integer. So if we try k equals 3, what's going to happen is it's going to take 1 there, 2 there, but it's going to take 3 there, and it's going to take, I believe, 4 there. Yeah, it's going to take 4. So that's going to be 1 plus 2 plus 3 plus 4, which is 10. So that's not within the time limit. So that means k equals to 4 is the minimum solution. And if you couldn't see, it's pretty clear that the time it's going to take, I'm just going to write it here, time to eat one pile is given by, well, it's going to be given by the number of, let's just call this piles I, the number of bananas in that pile divided by k, but then what we need to do is we need to actually ceil in this, because we want to get the maximum this is. So if this was 3, well, 3 divided by 4 is going to be about 0.75, but then this is going to actually take 1 hour. So we're just going to ceil it to the next largest integer. So this is a formula we can use. And now what you should be able to see is that if we just choose some random k, let's just choose a random k, then we can actually work out the time it's going to take for each pile in this. We can work out the total time it's going to take fairly easily by just using this formula on each item in piles to work out the total time it will take to eat all piles for any given k. So we can work out that total time easily, and what that also means is that we can check if it's less than or equal to h. So what that means is we need to figure out what values of k we want to test, and we want to test k from, well, the minimum we could possibly have is 1. If it was 0, it would never eat anything. So 1 is the minimum. You can go 2, 3, 4, all the way up to, well, the maximum value of k we'll ever need is going to be the maximum of this array. So for example, in this one, it would be 11, and that's because when k is equal to the maximum of the array, each pile is going to take at most 1 hour, so the number of total time it's going to take is going to be equal to the length of the array, and you can see that h is always going to be greater than or equal to the length of the array. So the maximum value of k which we could possibly ever need is just going to be the maximum of piles. If we start using k which is more than that, it's just unnecessary because it's still going to take 1 hour to eat any pile. So here's our list of possible sort of k values to test, and if we call another array total times, we can work out the total time taken for each of these k values. So let's say for 1 it's going to take 1,000 hours. That's way too high. Let's say it takes 1 takes 100, 2 takes 50, 3 might take 30, 4 takes 20, and this continues. Max piles, well, that's just going to take 4 or length of the array. And you can see if k increases, then the total times is always going to decrease, because there's no way a total time can increase if k, the speed at which they eat, increases. So this is a sorted array, and that should remind you of binary search to find, let's write it over here. Therefore we can use binary search to find the, so these are the times. We essentially want to find the greatest time, we want to find the greatest time before the greatest time which is lower than or equal to h, if that makes sense. So we go along this array. 100 is not lower than or equal to h, it shouldn't be, and we just go along until we find the first one which is lower than or equal to h. And since this is a sorted array, this can be easily done using binary search. So our left and right pointers are going to be set to k values. So we'll set the left one to the minimum value of k, which is just going to be 1. And the right one, right pointer, is going to be the maximum value of k, which is just going to be the max of the piles array. I wonder if there's a way to do this quickly. Yep, there is. We can use the math.max and then just pass in piles like so. So here's how we work out. That's the left. So left and right, these indicate all the possible k values, and we're going to narrow them down to get the one we want. So this is just regular binary search now. While left is lower than right, we calculate the mid k value, which is just going to be the mean of these two. I wonder if I can, okay, that's fine. Actually, I'll use bitwise shift just so we can ensure it's always going to be integer division. So this is essentially just finding a mean. This left shift is essentially just an equals, but then also included a math.floor. So it's just integer division. 5 divided by 2 is equal to 2. You can see that if I run it in Dino. Oh. Okay. That's weird. Oh, sorry. That's not what I wanted to do. This is gonna, the number you put after this represents the shift you want. So we want a leftwise, sorry, we want a rightwise shift of 1. And yeah, that's what I meant. Okay, so let's use a rightwise shift of 1. Essentially what it does is it shifts all the binary digits encapsulated in 5. So if we say 5 is going to be, well, this would just be 1, 0, 1 in binary. And when you apply a shift of 1 to that, that's now going to become 1, 0, and we lose the 1 at the end, which is equal to 2. That's basically how it works. Sorry for a slight hiccup. But yeah, so this is working out the mid k, and then what we're going to do is calculate the time which this mid k is going to take. So let's just call this let total time, and that's equal to 0. And I'm just going to loop through piles and add up the total time. So total time plus equals, using this formula over here, math.ceil pile divide by k. Sorry, mid k. like so. So we worked out our total time, and this is going to tell us where we are over here. So now what we want to do is we want to check if total time is, okay, so if total time is, let's say, greater than h, if it's greater than h, then this k value is invalid since it's too low. So k value is too low, so that means we need to just move it, it's too low, somewhere over here. We need to move it over all the way past that. So we're going to set left is equal to mid k plus 1. Otherwise, total time is less than or equal to h. So we are on a valid k. However, there could be a k lower. So we might be somewhere over here. Let's say we were on like this one over here. So this total time is going to be lower than h, but we might be using a really high k. And observe that the question asks us to find a minimum, so there could be a lower k. So we're in the right place, which is why if we just set the right equal to mid k, including it, whereas in left we set it to mid k plus 1, this should work. And yeah, from here, this is just going to continue until left is equal to right. And since we know there's got to be a valid solution, we can simply just return whatever value left is equal to. Once this loop ends, left is going to be equal to right, so it doesn't matter if we do return left or return right, they both do the same thing. But we'll just return left, and yeah, this should be the answer. So let's submit this and see how it is. Okay, so you can see it's accepted. We actually do manage to beat 78% of users. The memory is quite bad. Not sure why that is, because we're not actually creating any external memory apart from these variables. But maybe, okay, yeah, it's not too bad. But one thing we can do to actually increase this is, you'll notice calling this math.cl function every single time we go through this loop is going to be quite taxing. So if we could do something like this, where we use mid-k, and we kind of just use bitwise operations, since these are much faster than using math.cl, we could actually make our program a lot faster. So essentially what we're doing is we want to divide power by k, and then ceiling it. And notice what happens when we use the bitwise operation on a negative number. So let's say, right, so let's say we shift it to left by 1. Right, so you can see this has actually rounded it down now. The problem is, yeah, okay. The problem is with this, we can't actually control what the number here is. We can only control divide by 2 or 4. So if you're using a language which allows you to use integer division, you could just set total time as negative, then just minus the pi or integer divide minus k, but minus pi. So that would allow you to use integer division to round sort of up instead of down, and then just multiply total time by -1 to reset it back to the positive odd. That's just an idea, but unfortunately in TypeScript and JavaScript, I don't really know a way to use integer division, since bitwise operations only let you divide by 2 and powers of 2. So yeah, that was just an idea to possibly make it faster, but hopefully you guys understood how we've solved this problem. Thanks for watching, and I'll see you guys in a future tutorial. Bye!